Welcome back to the channel, guys, and our today's topic is recursion. First, we'll see what recursion is. Recursion is a technique where a function calls itself to solve a smaller version of same problem, which means, let's say there is function n. So when the execution of n function will start, then while executing, it will call itself again. So this can cause an infinite loop, which means the function will call itself again and again and again, and it can cause an infinite loop. So we need to stop it at a condition, and that condition is called base condition. For example, here you can see in this example, this is the base case. Means when n will become the parameter n which we are passing to the function, when it will become 0, then the function will not call itself and it will return. Now this is the base case. Let's say if we don't have this base case, then it will call the function itself again and again and again, and it can cause an infinite loop. So for recursion, the base case is mandatory. Now this function is for printing the numbers from 1 to 10 without using loop. We are avoiding the loop and we are using recursion here. So how the function will execute? First, it will check if the parameter passed to it is equals to 0 or not. If it is not equals to 0, then what it will do? It will call the function itself for the previous n value. Like if we are passing 10, then it will call the same function for 9. Same, then when the function of 9 will start, then it will again call the function for 8. I'll just show you. Yeah, here you can see. First we have passed the parameter 10. Then it will check if 10 is equals to 0. If 10 is not equals to 0, it will call the function for 9. Then it will check if 9 is equals to 0. Then if 9 is not equals to 0, then it will call the function for 8. Then 8 is also not equals to 0, then function will call for 7. And like that it will come till here. When 1 is not equals to 0, then function will call for 0. And here, once the function is 0, then the function then it will return. And when it returns, as you can see, after this it will print the value. So what it will do, here it will come, uh, it will start now backtracking. And while backtracking, here first it will print 1, then it will go to next, it will print 2, then it will print 3, and similarly when it will come here, it will print 8, here it will print 9, and here it will print 10. So first 1 is printed, then 2, then 3, 4, 5, 6, 7, 8, and 9 and 10. So we have printed numbers from 1 to 10 without using the loop, using recursion. And whenever we are calling recursive function, it stores the information in a call stack. Like uh, if we are calling for print 3, then it will call for print 3, then it will call for print 2, then it will call for print 1, and then for print 0. This complete functions information is stored in call stack, and once function for 0 is written, then it will start to execute backwards. Now one of the prime examples for recursion is factorial. Here you can see, 1's factorial is 0, 2's factorial is 2 into 1's factorial, 3's factorial is 3 into 2's factorial. Basically, mathematically, we can write that n factorial is equals to n into n minus 1's factorial. And also, the base case here is 0 factorial is 1. So, while writing function, what we'll do, we'll pass the number of which we have to find the factorial, and then we have to write base function that when n is equals to 0, then the it will return 1, as 0 factorial is 1. And after that we will return n into factorial of previous number. As here you can see, we have to just multiply with previous numbers factorial. Now what it will do, if we pass here factorial 3, so first it will check if 3 is equals to 0. If not, then it will return 3 into factorial of 2. Now factorial of 2 will be called. For factorial of 2, it will check if 2 equals to 0. If not, then it will call 2 into factorial of 1. Now it will call factorial of 1. For factorial of 1, it will check if 1 equals to 0. Then 1 is not equal to 0, then it will call 1 into factorial of 0. Then it will check if 0 equals to 0, then it will return 1. Now this 1 will go here, it will become 1 into 1. Then when it will go here, it will become 2 into 1 into 1, and when it will go here, it will become 3 into 2 into 1 into 1. So we will get the value for 3 factorial as 6. Then again, one of the prime examples for Fibonacci is, for recursion is Fibonacci. Here every number's Fibonacci, like Fibonacci of n is Fibonacci of n minus 1 plus Fibonacci of n minus 2. So, and the base case here are Fibonacci of 0 and Fibonacci of 1 are 1. When you call for Fibonacci of 2, it will do Fibonacci of 1 plus Fibonacci of 0. And we know that Fibonacci of 1 is 1 and Fibonacci of 0 is 0. So value for Fibonacci of 2 will be 1. Now Fibonacci of 2 we have got 1. When we will call for Fibonacci of 3, it will do Fibonacci of 2 plus Fibonacci of 1. And we know that Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0, whose value is 1. So we will do 1 plus 1 and it will become 2. Now we have got the value of Fibonacci 3 as 2. Now for Fibonacci 4, we will call Fibonacci 3 plus Fibonacci 2 and it will be 2 plus 1, that is 3. And that is how we will continue forward. The execution, first for execution we will see when we call the Fibonacci of 5, it will add Fibonacci of 4 plus Fibonacci of 3. Then for Fibonacci of 4, we will call Fibonacci of 3 and Fibonacci of 2. And similarly for 3, we will call Fibonacci of 2 and Fibonacci of 1. Now, in this tree, you can see that Fibonacci of 3 is calculated 2 times. Fibonacci of 2 is calculated 3 times. Likewise, in Fibonacci calculation, we are calculating the same problem multiple times. And this is a bigger issue because it can cause more time complexity, and this issue is solved by DP, that is dynamic programming. We'll see DP later. Now let's just focus on recursion. So for recursion of arrays, let's say we want to print all the values of array. What we'll do, we will write a function integer and we will pass array and integer n, that is the size of the array, and an integer I, which will be used for the iteration. Now what we'll do, we will check that if I is equals to n, that is iterator goes to the last position. When iterator will go to the last position, that will be our base case, and we will return from there. So and until if it is not reached the last position, then we will just print that iterator's value of the array, and this will give us the complete array. Now, here you should know that base case is very important for recursion, because without base case, the function will call itself infinite times and it can cause stack overflow, which means the stack space will run out. And the time complexity for recursion is big O of n, and space complexity is big O of n as well. Now we will see the code implementation. Okay, guys. So now we'll see the code implementation for recursion. Uh, we'll take the example of printing numbers from 1 to 10 without using the loop. So what we'll do, we'll just write a function print. We'll take integer as an input, and we'll just write the base case. If n equals to 0, then it should just return, and if not, then it should call for the previous value, that is n minus 1, and then it should print its value, that is n. And we'll just give gap a little, and that's it. Yeah, so here you can see, uh, if we give the loop print 5, so what this will do, it will call the function for 5, then it will check if 5 is equals to 0. If not, then it will call for 4. Then again function will call for 4, it will check 4 equals to 0. If not, then 3, then 2, then 1, and then 0. Now for 0, it will check 0, then it will return. Now the function call will come for function of 1, and it will be here, then it will print 1, then for 2 it will print 2, then for 3 it will print 3, then for 4, 5 it will print. I'll just show you the output once. And yeah, here you can see the output 1, 2, 3, 4, 5. Now what happens, we are calling the function for previous value and then we are printing, means whatever we are giving the parameter, it is executed at the last. What if we want to print the list in the opposite manner, or we want to print 5 first, then 4, then 3. What we'll do, we'll just see out the value before calling the function for next number, and this will give us the completely opposite output. I'll just show you once. Here you can see 5, 4, 3, 2, 1. Now I'll just show you the function implementation of factorial. We'll write a function factorial. Let's say int factorial. Parameter will be a number. What we'll do, we'll just check if number is equals to 0. If the number becomes 0, then we'll just return 1, and if not, then we will return n into factorial of n minus 1. Yeah, now we'll just check the first. We'll add a line break here. This is the line break. Now we'll call for the function factorial. Let's say we want the value of factorial 10. So what factorial 10 will do? It will check if the 10 is equals to 0. If not, then it will call 10 into factorial of 9. Then function factorial 9 will be called. 9 equals to 0. No. Then 9 into factorial of 8. Then 8 into factorial of 7. Then 7 into factorial of 6. And so on till 1 into factorial of 0. And when factorial of 0 is called, it will return 1. So it will become 1 into 1 into 2 into 3 into 4 into until 10. And I guess I don't know the value of factorial. Let's just check the output and we will get the factorial value of 10. Okay. Yeah, we are not printing the value actually. We'll just take the factorial 10 in a variable x, and then we will see out x. Okay, now we will get the output of factorial 10. Here, the value of factorial 10 is 3628800. If we take factorial of, we'll take easy number so we can guess the number. So factorial of 3 is 6, as we already know. I'll just check the output. Okay, here you can see it is 6. Let's say if we do the factorial of 5, the answer should be 120. And here you go, 120. So this is how factorial works. Now let's just check Fibonacci once. Right, sorry, int Fibonacci, parameter will be n, and we'll start the function for Fibonacci. First we have to check if there are two base cases. If n is equals to 0, then we have to return 0, and another case is if n is equals to 1, then we have to return 1, and in all other cases we just have to return Fibonacci of, sorry, Fibonacci, Fibonacci of n minus 1 plus Fibonacci of n minus 2. And yeah, here you should get the value of Fibonacci. I'll just check the value in 1. Fibonacci of, let's say we want 5. I know that Fibonacci value of 5 is 5. So output should be 5. We'll just run the code. First we'll clear the terminal. Now we'll run the code, and here you can see Fibonacci value for 5 is 5. Also Fibonacci value for 6, I don't know, I guess it is 8. So we'll just check the value for 6. I think for 6 it is 8. Yeah, here 8. For 7 will be 8 plus 5, 13. For 7 it will be 13. Okay, 13. Let's just take the value of bigger. Let's say we want to find Fibonacci of 1000. What it will be? Oh my god, it's too big calculation, I guess. There are multiple function calls. It is taking too much time, guys. Okay, Fibonacci of 1000 is taking too much time. Let's just call a smaller value. Let's say we call Fibonacci of 50. So for Fibonacci of 50, what the value will come? Okay guys, it is taking too much time. Let's just take it for 10 once. Okay, yeah, the Fibonacci value of 10 is 55. So these were the prime examples of recursion, factorial, and Fibonacci. I'll just show you printing the array with recursion once. Let's say we are taking an array and array of size 5. We have 89, 78, 50, 25, 65, and 36. So these are our 5 values and we want to print them. First we'll write the function for printing. Void print array. The parameters will be first function, after that size of the function, so first array, size of the array, and an iterator I. And what we have to do, our base case will be till iterator goes to the last element, that is I equals to n, and when it goes to the last step we'll just return, and until then we'll print the value array of I space. That is it, I guess. So now let's just call the function. At the end we will call print array. We will pass array, size is 5, and iterator, let's say we have iterator I equals to 0, or instead you can just give directly 0, sorry, and the output should be 89, 78, 25, 65, and 36. We'll just check it once. 89. Oh, sorry guys, I just forgot to call the function again. I mean, I did not even use the recursion. How can I expect the answer? So we have to write the function again. Size same, and I plus 1. Okay, this should do it. Yeah, we are good to go. 89, 78, 25, 65, 36. Okay guys, this was it for recursion. I'll see you in the next video. Thank you.